All right, now, let me see if I can get more paper here. I want to go ahead and do a video that covers a bunch of the problems from 16 to 26, 15 to 26. We haven't done 15 to 26. 15, you don't really need to know right now, and you don't really need to know 26. Those both deal with what they call the periodic nature of your trig functions. You know, as you wrap around the circle, you have like a lot of angles that all have the same sign, value, etc., because these functions are periodic. So you keep getting repeated values that are equal. Well, we talk a lot about that later. Okay, so I'm going to just wait to do 15 and 26. So right now I want to do the rest of these, 16 to 25. Okay, so the directions are to find the exact value. These are important. I hope you'll really listen to this, because if you don't approach this, if you just type it into your calculator, you're not going to get any credit. Find the exact value of each expression. Do not use a calculator. Okay. All right, so I'm going to do these thinking about both either the special right triangles or the unit circles. So let me go ahead and draw a couple triangles here that we can refer to. Okay, and get those ratios labeled. Okay, so if you have 45, 45, 90 or 30, 60, 90, we know a lot about them. So that's how a lot of the problems from 16 to 25 are going to be able to be done. Okay, other thing we can use is the unit circle, okay, which has those special angles sometimes on there. And I'll fill it in as I need it. All right, so let's go ahead and do a bunch of these. So on 16, I'm being asked for the tangent of 30 degrees. So I can just look at the 30, 60, 90 triangle, and I know it's opposite over adjacent. And when I rationalize that, I'm going to get square root of 3 over 3. Done. Okay. 17 wanted the cotangent of 120 degrees. So I want to think about that one a little bit. So if you think about 120, that would be 90, a little bit past 90. So if that's 120 and over here is 180, then that means this reference angle right here is really 60 degrees, isn't it? Okay, so I want to think about that reference angle being 60 degrees. Okay. And then also cotangent is not something I naturally think about. I would prefer thinking about tangent. So since the reference angle is 60, that's what I'm going to think of first. Okay. I go to my 30, 60, 90 triangle and I see the tangent of 60 would be square root of 3 over 1, which is square root of 3. Okay. So now I'm thinking about, well, I didn't want tangent, I wanted cotangent. So the cotangent of 60 would have been the reciprocal, which would have been 1 over square root of 3, which is square root of 3 over 3. And then I got to think about, yeah, but I didn't want cotangent of 60. I wanted the cotangent of 120. So I have to think about the fact if I'm in that quadrant, the coordinates of those points are negative, positive. So tangent and cotangent are both going to be negative in that quadrant. So this is going to be negative cotangent of the reference angle, which is negative square root of 3 over 3. All right, so let me take that a little slower, because this is what, I don't want you just typing this in on your calculator. All right, 120 had a reference angle of 60. So that's why I was focused on the 30, 60, 90 triangle. I personally, if I'm faced with cotangent, I actually think it through by thinking tangent. You may not need to do that. You may like to just directly do cotangent. All right, so either way, you're going to wind up eventually with the cotangent being square root of 3 over 3. But you have to watch it. This was your theta. This was your original angle. This was the reference angle. These don't have the exact same values. You might need to put a negative on them like we did here. In this case, we're in the second quadrant. So we did need the negative on that. 60 would really have been over here, and everything would have been positive. So your final answer on that should have been negative square root of 3 over 3. Okay? All right, let's use this same picture for number 18. 18 is talking about the cosine of 240, cosine, 240 degrees. So I'm going to think about that. I'm going to do this one in blue. So same picture, but 240. So 240 would have been all the way to 180, and then you would have gone past it to get to here. That would have been 240 degrees. This would have been 60 degrees again. Okay, we're dealing with cosine now, though. Let me move this back down so we can see it. Cosine of 60. Cosine of 60, here's what your thought process should be. Cosine of 60, go look at the triangle. It would be a half, wouldn't it? So the cosine of 240 should equal basically the cosine of 60, but I got to think about whether I need a negative on that or not. Because 60 is in the first quadrant, so its cosine is positive. But see 240? It's over here where if you were a point in that quadrant, wouldn't you be negative, negative? So the cosine would be negative, so you do need to throw a negative on that. So your answer is going to be negative 1/2. That's the way you reason it out, and that's the way you'll have to share with me how you reasoned it out. Okay? All right, now we're getting into some triangles that are expressed in radian mode. Okay, so we could go to the unit circle, or you could see which of these special right triangles would work. Okay, so let me go ahead and look at a question like number 19. All right, with number 19, we're asked to find secant of 11 pi over 6. Okay, so if we're using the special right triangles, first thing I'm going to do is figure out where I am. If I had gone all the way around, I would have been 12 pi over 6. Right, that would have been 2 pi. So I have to be back here a little bit, which means this reference angle right here is pi over 6. So if I'm trying to use special right triangles, I do need to kind of realize that pi over 6 is really 180 over 6, or 30 degrees. Okay, so then I would look and consider a 30, 60, 90 triangle. And secant, when I'm doing it, sometimes I just always think sine, cosine, and tangent. The cosine of 30 would be square root of 3 over 2. Okay, secant of 30 would be 2 over the square root of 3. And you would rationalize it. So you'd get 2 square root of 3 over 3. So now you have to think about the quadrant you're in. Pi over 6 is really in the first quadrant, so its cosine would be positive. 11 pi over 6, though, also has a positive cosine because you have to go to the right. See how the x-coordinate is positive? So you know this really is going to be positive 2 square root of 3 over 3. Okay, and that would be that one. All right, now number 20 doesn't really go with the others in a way. It's actually trying to use the fact that sine squared theta plus cosine squared theta is a common identity. This is the Pythagorean identity. So no matter what the angle is, if it's the same on both of those, then you're going to have 1. So they put a 5 over 7 on each of these. I mean pi over 7. And so sine squared pi over 7 plus cosine squared pi over 7 has to equal 1. Okay, so it's not really the whole reference angle type thing. All right, now with 21 had a negative. It was sine of a negative angle, negatives 2 pi over 3. Okay. All right, so let's just think about where that is. So since the denominator's 3, I'm breaking up pi, this bottom part, into 3 equal pieces, and I need to go 1, 2 of those. So this would be negative 2 pi over 3 right here. So see how your pi over 3 away from the x-axis, that's your reference angle. So the sine of pi over 3, if I'm thinking about 30, 60, 90 triangles, it helps to get it into degrees, would be the same as sine of 60 degrees. And the sine of 60 degrees would be square root of 3 over 2. All right, now I'm in this quadrant right here, which has negative, negative. So the sine value is going to be negative. So I need to put a negative on that, but it'll be negative square root of 3 over 2. That's the approach. That's using reference angles to figure out these, not just plugging that into the calculator, okay? All right, so let me get some more paper. 22 is cosecant of 22 pi over 3. So that's angles had a lot of rotation. All right, so the denominator's 3, so I'm thinking about breaking things into thirds, top and bottom. So 1, 2, 3, 4, 5, 6 would be all the way around once. If I go all the way around a second time, I'd be at 12 pi over 3. Third time would be 18 pi over 3. Okay, so it's like this angle. You've gone around once, twice, 3 times. That's at 18 pi over 3. Then that's 19, 20, 21. This would be 22. So that's where you're at. So how far past the x-axis are you? See how you're only 1 pi over 3 away from the x-axis? That's your reference angle. All right, so if I knew the cosecant of pi over 3, I would just adjust and put a negative on it to get the cosecant of 22 pi over 3. I know this would be negative since cosecant is related to the sine, and if I'm in that quadrant, both coordinates are negative. So I know it's going to be negative, whatever the cosecant of pi over 3 turns out to be. Okay, so pi over 3 again is 60 degrees. So if you're using triangles, you need to think that. So you come in here, if you didn't already have them sitting right next to you, just recreate it. Okay. And then you can think cosecant outright, or if you do like I do sine. So sine of 60, square root of 3 over 2. So cosecant is what I meant to draw, of 60 would be 2 over the square root of 3. Okay. So this would be 2 over the square root of 3. And in that quadrant, I need to be negative. So it'd be negative 2 over the square root of 3, but I got to rationalize. Oh, I hope you followed this okay. I'm getting tired, so I'm kind of all over the place. So should be negative 2 square root of 3 over 3. All right, I want to do just a couple more so that we can get to a stopping point. Okay, and remember, I'm also having face-to-face virtual sessions, so that might be something you can participate in as well. All right, 23 is cosine, but it's of a nice big angle. First thing I'm going to do is knock off a rotation there, and that'll get me down to 135. Cosine of 495 exactly would equal cosine of 135 because these are coterminal. I don't even have to worry about adjusting them. Okay, so 135 is there. So like 495 just goes around one whole time first. 135 just goes boom. Okay, both of those have the same cosine. All right, and then let's do this one thinking about the unit circle. So you know how this is 45 degrees over here, and 135 is over there. And on the unit circle, you know how it's square root of 2 over 2 for both. So this is going to be square root of 2 over 2 for both, except you go to the left and then up. So it's negative on that first quadrant. So I could use my unit circle if they allow me to, and then I know cosine of 135 is going to have the same number part as 45, and then I would just throw a negative on it. See, 45 degrees is the reference angle. And so I could do the cosine of 45. I could have used my special right triangles if I wanted to get that, and then just throw a negative on it because you're in the second quadrant and cosine is negative there. Okay. All right, now let's take a look at 24. We're doing tangent. We have a negative 17 pi over 6. I usually just draw a picture, see where I'm at, but I'm going in the negative direction. So around once would be 12 pi over 6. Denominator 6, so I'm thinking about things broken into 6 pieces. Okay, so that's negative 12 pi over 6, 13, 14, 15, 16, 17 would be right here. You're 1 pi over 6 away. So what you could do is find the tangent of pi over 6. You know it's going to be the same number part, and then just decide out here whether you need to throw a negative on it or not. And that's, again, 180 over 6, that's 30 degrees. So you can think about your special right triangles, or you can go to this location on your unit circle. I think about the 30, 60, 90 triangle. Tangent is opposite 30, opposite over, that'd be 1 over square root of 3, which would be square root of 3 over 3. And then tangent in the third quadrant, since it's negative, tangent is positive, isn't it? So it's going to exactly equal the tangent of pi over 6. So it's going to just be square root of 3 over 3, and that would be your final answer. Okay. All right. And then 25 is the last one I want to do on this video. And then I better quit because I'm getting tired. I'm afraid I might be rushing things. Here we have sine squared, but it's sine squared of pi over 2. Then they want us to subtract cosine of pi. Okay, now both of these are quadrantal angles. Let's go to the unit circle. Okay, so let's think about these 4 points right here. Okay, that's 1, 0. This one would be 0, 1 if we're on a unit circle. Negative 1, 0, and 0, negative 1. Pi over 2 is up here, isn't it? Because you cut pi into 2 pieces. It's the same as 90 degrees. Oh, you don't need to switch to degrees. I was just making that connection. And then here's where pi would be. It's the same as 180. All right, so this sine squared pi over 2 means sine of pi over 2 times itself. So the sine of pi over 2 is the y-coordinate, which is 1. So it's 1 getting squared. And then cosine of pi is here. Cosine is the x-coordinate, so that part is negative 1, but then be careful, you got a minus in between. So this is 1 minus negative 1, which is plus 1, and your answer to 25 should be 2. And that would be your final answer. Okay? All right, so I wanted to just go through some questions from 5.1 to 5.4. 5.1 to 5.4 gives us the foundation we need to be successful in the rest of the sections, really sets us up for success. So really work hard on this. So this was from that handout I gave you, page 598. And then there's a review in my math lab that you're to do. that covers these same concepts. And once you do it, you'll have a personalized homework that'll be created where you'll have access to some videos and that sort of thing, okay, through My Math Lab. You'll have access to examples and videos and that sort of thing, okay? So really study hard and work to make sense of these, okay? Set aside that time to really focus on it. All right, I'm going to stop this one.